All right, we're going to dive into a pretty provocative idea today. It comes from an article that basically claims everything you've learned about software engineering, well, it's all about to become optional. The premise is simple, and it's brutal. Code, as the main thing we care about, is dead. Let's get into it.
So the author just comes right out of the gate with this challenge. And it's not really a question, is it? It's more of an accusation. It's meant to make you a little uncomfortable, to set the stage for tearing down how we usually do things. It's basically saying, if you're still obsessing over every little implementation detail, you're already playing yesterday's game. To really make this point hit home, we get this really high-stakes scenario. Imagine this. You're trapped on the second floor of a burning building. A firefighter is coming up to rescue you. Now think fast. What are the stairs they're climbing made of? Are they steel, bamboo, some kind of fancy folded wood? Right. You have no idea, and you absolutely do not care. The only thing in the entire world that matters in that moment is the function of those stairs. Can they support the weight of the firefighter coming to save you? If the answer is yes, they're great stairs. If the answer is no, they are very, very bad stairs. That's it. That's the entire review process.
And this is the core mantra of the whole idea. Did it work? Ship it. Nobody's checking if the stairs follow solid principles. Nobody cares if the joints are dry. Did it accomplish the mission? Yes? Then it's done. This is the radical new philosophy being introduced, function-driven development, or FDD.
Okay, so let's dig into the actual philosophy here. I mean, the burning building is a great hook, but how does this really apply to our day-to-day writing software? The argument is that we need a completely new contract with our code, one that's based entirely on the outcome. And here's a perfect analogy for anyone who's ever worked with a database. Think about a SQL query. You just declare what you want, right? Select users from this table where this condition is met. The database goes off, does its thing, and gives you a result. You don't care how it did it. You're not reviewing its B-tree implementation. You only care that you got the right data and you got it fast. So here it is, the formal definition. FDD basically treats the actual lines of code, the implementation, as a disposable byproduct. Yeah, you heard that right. Disposable. The only thing that really matters, the only contract you have, is with the function itself. Does it do what it's supposed to do? And this brings us to what the author calls the Supreme Law, which is just a fantastic way to put it. It's totally absolute. It's not about, is this clean code or does this follow best practices? It's about one thing and one thing only. Did it deliver the outcome? The how it did it becomes completely secondary to the what it did. Now, I know what you might be thinking. This sounds like complete chaos. Like we're just going to ship messy code and cross our fingers? But no, FDD actually proposes a very specific system to make this work, to build it into a real, reliable architecture. The basic building block of this whole system is something called a single-purpose microservice, or SPMS. And the rule for designing one is, well, it's pretty wild. It has nothing to do with lines of code. The rule is simply this. Can an AI understand the service's complete context, all its requirements, its history, its issues, in one shot? If not, the service is too big. You have to split it. The AI's context window literally becomes your new design principle. Now get this. Each of these microservices is defined by just 3 things, and I want you to notice what's not on this list. The 3 artifacts are the product requirements, what does it do, the changelog, this is all the history, the weird edge cases, the tribal knowledge, and finally, the tests. This is the non-negotiable contract of its behavior. The code itself, it's not on the list. And that's completely intentional. So this is the actual workflow. Doesn't matter if you're adding a new feature, fixing a bug, or even doing a refactor. The process is always the same. You take those 3 artifacts, you add your new request, and you feed the whole thing to an AI. The AI then generates a brand new implementation from scratch. If that new code passes all the tests, you ship it. If not, you iterate. You're not modifying old code anymore, you're regenerating it. Okay, I can practically hear the objections through the screen. This sounds wild, maybe even a little irresponsible, right? Well, the author anticipates this and tackles the biggest what-ifs that any experienced developer is going to have right about now. First up, the big one. What happens to technical debt in a world where an AI is just churning out code? Aren't you just building up an unmaintainable nightmare? And here's the answer. It's a huge paradigm shift. Technical debt only matters if you actually have to maintain the code. The argument is, if regenerating a fresh, clean implementation from scratch is cheaper and faster than having a human go in and fix the old one, then the concept of debt becomes meaningless. The code is disposable. You just throw it away and make a new one. All right, fine. But what about security? Come on, surely we can't just trust AI-generated code with anything sensitive. That feels like a massive, massive risk. The answer here is that your validation process doesn't change, just the source of the code you're validating. Big companies already use security audits and vulnerability scanners. In an FTD world, you do the exact same thing. You run your scans on the AI-generated code. If it passes, you ship. If it fails, you add that failure as a new requirement, you regenerate the code, and you scan it again. Now, it's really important to understand that this isn't a silver bullet for every single line of code you'll ever write. And the author makes a really crucial distinction here that adds a necessary dose of pragmatism to the whole idea.
See, not all code is created equal. On one hand, you've got what the author calls commodity code. Think of your internal Slack bot, or the script that generates a weekly report. For that stuff, the does it work, ship it mentality is perfect. But then, you have critical code, your payment processing engine, a high-frequency trading algorithm. For that, you absolutely need to understand every nuance of the implementation, because you're the one getting woken up at 3 a.m. when it breaks.
But here is the real kicker. The author makes the claim that the vast majority of code that we all write day in and day out, a whopping 90% of it, falls into that first category. It's commodity code. It's the simple stuff. And if that's true, it means the FTD approach isn't just some niche idea. It could be the default for most of the development work we do. So, if we accept this premise, even just for a minute, it means more than just learning a new workflow. It really demands a fundamental shift in how we think about our jobs as software developers. Your job description basically changes. You're no longer a craftsman of code. You become an architect of outcomes. Your job is to maintain crystal clear requirements, a super detailed changelog, and rock-solid tests. The code itself becomes this temporary implementation detail that you just regenerate whenever you need to. Your core skills shifts from implementation to communication and specification. And this, right here, this captures the entire mindset shift in a nutshell. We need to move away from asking if the process was good and start asking if the outcome was good. The quality of the code becomes almost irrelevant, as long as the function is delivered correctly, securely, and within the performance metrics defined by your tests. So we end right where we began, back in that burning building. The author's final point is that this isn't some far-off hypothetical future. The fire is real. AI is changing the economics of building software right now, as we speak. So the only question left is, how are you going to adapt? Are you going to keep debating what material the stairs are made of, or are you going to focus on making damn sure they can hold the firefighter?